Okay. Am I good to go? Okay. Hello everyone, welcome, good evening, and welcome to my talk about reactive extensions for JavaScript. The screen is doing some blinking spontaneously, so I hope that doesn't continue to go on. If that's the case, we will appropriately react to that case. So I'm Bart, I'm working in the cloud programmability team in Microsoft, where we do stuff around data access in the cloud and those kind of things. And one of the things we've been working on is looking at event processing systems, like how do you basically program in a world where data comes to you in an event-driven fashion, basically meaning that instead of actively querying a database, you basically register the fact that you're interested in getting notifications about things are changing in for example, a stock ticker. And so we've created this library called Reactive Extensions that allows you to do that kind of stuff. So first of all, why should you care about event processing? Let me sort of start by stepping back a little and taking a look at the whole domain of event processing systems, and we'll see it's really omnipresent, it's everywhere. So if you take a look at this slide, you see a lot of places where events basically come at you. Whether you like it or not, events are being streamed to your application. Simple example includes stock tickers. Well, you're not going to sit there and wait for the stock to change. It just happens, and you get notified about the fact that the stock has changed. And then your application somehow needs to react to that particular event. Similarly with things like RSS feeds. Maybe behind the scenes there is something that's pulling the RSS feed to get updates, but your programming model, ideally, you just want to sit in your application, do useful stuff, and at some point an event comes in saying, hey, there is a new post on a particular blog on a news site. And you want to react to that, process that particular event. Similar for things like GPS and the geolocation service in HTML5. You can basically say to your browser, please update me whenever the user is in a different place. And your application picks up the new long-lived coordinates and you do something with that. A lot of other things over here, including social media, Twitter. In most cases there, you're basically listening to some stream of which 100% of the stream is crap in a lot of cases, so you want to filter out just that one post that you're interested in. Well, you need to do event processing on top of a Twitter stream in order to accomplish that. So there are a lot of domains out there. However, there's no such thing as unification. Like, once you know how to do the stock ticker API of, say, NASDAQ, well, you haven't learned anything about how to program the geolocation API or how to deal with Twitter. They all have different ways to do callbacks and all of that. So Rx is basically an abstraction that allows you to combine all those worlds behind the same abstraction called an observable sequence, and then write those complex event processing systems on top of that, where you start doing things like filtering or windowing with time and all those kind of complex scenarios. So let's now take a look at the particularities of Rx in JavaScript, because we have Rx for a lot of platforms. We have it for the .NET framework, we have it for Silverlight, we have it for XNA, we also have it for JavaScript. And so in JavaScript there are some specific things that stand out with regards to the language that force you in thinking about asynchronous programming. Now, asynchronous programming and event-based programming is pretty similar. Basically, you start some computation, and then you listen to an event that basically triggers when the data becomes available. For example, you do an AJAX call. Well, basically, you're waiting for an event. Well, not actively waiting, as in being blocked, but you schedule a callback, and that callback function then handles the rest of your program. So the result of that is that your control flow starts looking funny. You basically start your AJAX call, and then you have a lambda expression, a function, that gets called when the data arrives. And your code starts to be indented, right? You start something, and you have a callback function, and maybe in there you start something else and have a callback function, and so on. So there's a lot of plumbing that you typically need to do. Now, there are also different programming models. And all those programming models, it's the same as in the previous slide, but now particularly to JavaScript, all those programming models have a different way of dealing with event systems. So for example, DOM events have a different way of handling clicks and mouse moves compared to like how you do it in jQuery, how you do it in AJAX. Like, it's all based on events, but the shape of the API is fundamentally different. So there is actually lack of unification. So here's an example. In order to deal with this particular AJAX request, you better know that you need to pass in some JSON object, and the callback is now called success. Now, in some other place, the callback might be called something else, because the API chose that's a more sexy name. So essentially, you don't have much unification in that world. So what do we do is actually unify that, but before I go there, let's show two concrete samples and sort of dissect a piece of code and sort of look at the essential building blocks. So first of all, here I'm using the DOM, simply get element by ID, I get some HTML element, and now I register some callback by basically assigning a function to the onMouseMove property. Now there are two parts to this. You have the DOM event, which is a little bit misnamed here because the on part is not about the event, it's about how you handle the event. Like it's really the MouseMove event that you're interested in here. And secondly, you have an event handler. And it also tends to be the case that all those event handlers that you have in those systems, acquire a lot of plumbing, imperative-style code to do things. For example, in this case, I'm basically reshaping my event and saying, well, this event is kind of nasty. I'm not interested in all that stuff, which button is down on the mouse or whatever. I'm just interested in the x and y coordinates, and I want to project that into a JSON literal or object that contains an x and y property, because that's what I'm interested in. So you start to write all that imperative code inside your handlers. Now here I have a second example of Twitter. In this particular case, I'm making some call, get JSON, some magic JSON objects I need to pass in to start a query. But now the way to specify the callback is quite differently. Now I have to pass it in to this particular request as the second parameter. But again, you have a blue part and a yellow part. You have the event source, which is the blue part, and then you have the way to receive updates, which is, in this case, the yellow part. And again, you see that you start writing imperative code in the event handlers. So how do we want to unify all of that stuff? Well, we do that by introducing observable sequences. This is a little annoying, so it's basically preparation for the blinking lights at the party. We set it up especially for that. I hope I get away with that argument. But so we're actually moving towards a unified programming model by introducing exactly two abstractions. The first abstraction is called an observable sequence. So an observable sequence is the producer of an event. In this case, a DOM event, an AJAX call. You can all implement the same interface and expose them as observable sequences, and we'll see later how that works. On the other end, we actually have consumers, which we call the observers. And the observers are basically the event handlers that basically contain the continuation of your program execution. When the event arrives, I want to do this and that. So what's the interaction dialogue between the two? The first thing you do is you say, hey, dear observable, say, for example, a stock ticker, I'm interested in receiving notifications whenever you have some data available. And the way you do that is by calling a function called subscribe, giving it an observer object. Now, as soon as you do that, you can move on with your life. You don't have to sit and wait there for things to happen. But in the future, asynchronously, you might actually get data pushed at you saying something has changed, a new tweet has arrived, the server is down, whatever your data source is. And so you get a push-based data source. The data source pushes data at you in your application. So that's basically the dialogue. And let's make it concrete using some code. Again, the same picture, but now with some declarations on top. We have an observable on the right, we have an observer on the left. The subscribe method or function looks like this. It's a function that takes in an observer, and then it does something with that. It also tends to return some object, which is an iDisposable, I will talk about that later, to actually unsubscribe, but that's a separate aspect. Now, once we have subscribed, after the call to subscribe, your code can start doing other things. Processing UI stuff, starting another request, whatever. You're not blocked till something happens. But ultimately, what's going to happen is that notifications come out of the observable sequence and get pushed at the observer. So for example, here, what you see is that data arrives on onNext function that receives the data and does some processing. Now, besides the onNext handler, which is basically about receiving data, like, for example, the coordinates of your mouse at a certain point in time, or getting the response to an AJAX call, you can also have two other functions called onError and onCompleted, the first of which is used, of course, to signal an error that happened, like because you're dealing with networking and those kind of things. You quite often have error cases. And there's also something called uncompleted. So in the next slide, which is coming up in just a moment, this is really annoying. I'm basically detailing the way that, that basically this interface looks like. So on next, basically, you can get 0 or more calls to that, saying there is new data available. Like if you think about an AJAX call, you will typically see just exactly one call, unless something goes wrong, saying, here's the result of the computation. Now, in case of mouse moves, of course, well, that sequence is infinite. You will get on next, on next, on next. Every time the mouse moves, you get a new location, a XY coordinate object. So you can have 0 or more. On error, then, is there because calls can fail. Here I have an example of a callback for an error case with regards to the geolocation API. So this new HTML5 API, you can actually specify a success callback, which will actually get triggered every time the position of the user is changing. But you can also specify an error callback that actually says, well, I can't get a location now. And you can handle that separately, and that will come out on the on-error channel of the observer. And finally, we have something called uncompleted, which indicates the end of a sequence. Like, for example, an AJAX call will have an onNext method being called, and then it will call uncompleted to say there are no results to follow. The sequence is finite, it's ended over here. And then you can sequence things, like Rx has operators like concat, where you can basically concatenate multiple observable sequences. And what happens is that the second sequence in that concatenation only starts executing when the first one completes. So that's sort of the sequencing point for those kind of operations. This also allows for automatic resource management, because if something completes, you know that the whole processing pipeline for the events can be taken down because nothing is actually receiving data anymore. Don't know what's going on here. So here I have an example of a couple of those event sequences. We draw those using those diagrams that we call marble diagrams. So a marble diagram is basically a line of time on which we draw 3 icons. One is a bullet that basically represents on next, and then we have a vertical bar that represents on completed. So this is a valid sequence of events. Here's another source that doesn't end with an uncompleted, but it's a source that ends with an on error. Now, one thing you should know is that errors are terminating just like successful uncompleted calls. Nothing can be after an on error call. So that's basically one of the ways that we structure things. We have a way to basically escape from that by doing something called materialize, but I won't talk about that today. But that's basically the semantics that you also see with exceptions. Exceptions are also terminating. They start to unwind the stack, and then you can handle the exception. And in Rx, you can do a very similar thing. We have an operator called catch. So you can have an observable sequence, you do .catch on that, and then you can specify a piece of code that will execute when on error triggered. And you can return a new sequence, and you can retry things and whatever. So the grammar of observables is as follows. You can have any number, including 0 and infinite, number of on-next calls, followed by either uncompleted or on error. That's basically the contract of the API. So let's actually go into an example of why we even would like to move things into the observable domain. Why can't we just use AJAX and DOM and all those things? Well, say, for example, that you have 2 streams of data coming at your application with notifications from social media. And after a little bit of shuffling in your event handlers, they are both sources that produce strings. How do you merge those things together and write a single callback handler that deals with both of them? And when something fails, everything propagates correctly, and when one thing completes and the other thing completes as well, the sequence itself completes. It's a lot of state management going on to do that. So in Rx, you can actually write something like Twitter, which is an observable with strings, .merge another observable of strings. And actually in JavaScript, they don't even need to be observable of something, because everything is loosely typed. But so here I have an example where I basically do that. I subscribe to twitter.merge, and that by itself gives rise to subscriptions to the 2 sources that the merge actually holds onto. So now you have a single observable object that you can program using all the Rx operators, and we have a whole slew of them, like about 50 or so. And basically, all the state management is done on the inside. And so what you see now is that you have a single line with events that actually merges all the events from both sequences that are being merged together. So now I have a single observable that I could hand out to some other function in some library that says, if you give me a notification stream of social updates, I will be able to render that, maybe on a map or something. Like, now you have a single object that aggregates, data from multiple data sources. Now, how do you create those observable sequences? So far, I've basically said this is the contract, and this is how you merge them. But, of course, you want to create them as well. So the first answer is we have a number of factory functions which are there, and they are useful. Later, we'll actually see how you actually bridge with the real world in JavaScript, but let's first focus on those to get, sort of a feeling for how you interact with the API. So here I have RxObservable.range. You will actually see that all those things are mirrored after link to objects in C# and VB and the .NET languages. It's exactly the same API, but for events. Plus some extensions which make a lot of sense in cases of event processing systems. And so in this case, observable.range, when you subscribe to that sequence, your onNext handler basically gets called for values 0 through 4. The 5 actually stands for the number of elements, so it's actually start, count. So this is how it looks. Now, you might say, well, didn't Bart say that subscribe takes in an observer, not just a single callback function? Well, we have some kind of overload, and that's like an overloaded term in JavaScript, but we have basically the capability to pass in either a function or an observer. And depending on what you give us, we will basically do the right thing. So in this case, if you give a function, you basically say, I'm not interested in exceptions or completion messages. I'm just interested in the onNext handler. And so that's something for observable.range. It's totally acceptable because, well, there are no exceptions coming out of that. Here's another sequence. It's called observable.return, which basically is a sequence that contains a single value, meaning that if you subscribe to that, that value gets immediately thrown at you. Now, I've used a very important word here, which is immediate. Like, if you do asynchronous computing, how does this actually work in terms of, like, immediate? Like, immediate means there is no concurrency happening in the system. Like, my subscribe will have returned, but the data will already be processed or produced. And that's actually the nature of those generator functions in JavaScript. Well, they complete immediately because they are finite. But later we'll see that when we bridge to, for example, the DOM, well, subscribe will not be a call that does anything. It just sets up the pipeline, and then in the future, that callback function will get invoked when data becomes available. Now, here's another one. It's called fromArray. Now, fromArray is a very useful one because once you have those observable sequences, you will see that you can write pretty complex queries on top of them to coordinate, multiple of those data streams together and do lots of, interesting processing mechanisms on top of them. Now, how do you test your application afterwards? You have that whole pipeline that, at one hand, sort of holds on to an AJAX call. Somewhere else, it holds on to a DOM event. Somewhere else, it holds on to the geolocation API. And now you say, I need to test that. Well, you say, I take my car and I drive up the mountain so that the coordinates are changing, and in the meantime, I'm clicking the button the whole time while I'm steering to basically sort of see whether my processing system is doing the right things. Well, the answer is because everything is an observable, you can just take out all of the sources and replace them by a mock object that actually represents, mimicked input. And one of the ways to do that is by doing observable from array. Like you could say, I have lots of, I have a painting program that paints on the canvas using mouse moves. Well, I want to see that a rectangle comes out if I give it an array of points that actually describe a rectangle. Well, what do? You just create an array with the points of a rectangle. You give that as the observable sequence as the input, and you look that the output is a rectangle. Nobody had to move the mouse to do so. You can simply substitute inputs for something else. And that's the beauty of having a single abstraction. You can do that for everything that's asynchronous. Now, it took a really long time, so it's getting better. So here's another one. It's called timer. Now, what's observable.timer so interesting about is that it's one of those guys that really is asynchronous. Basically, you set up a timer, nothing happens until the user does subscribe. And so that's what's going on here. Once we reach the line of subscribe, that sequence is actually happening and events are coming out, and that's actually a pity because of the nice effect. But the events are coming out 0, 1, 2, and 3. The first one, 1 second from the start of the subscription, and then every 2 seconds the next one comes out. think it's something with this VGA thing. I never have it when I'm just using the machine, whatever. Now, the interesting thing here is that your application can do work while that subscribe is active. Your event handler is hooked up, and you can do other things in the meantime until somebody says, I'm not interested in getting those timer tick events anymore. I want to get rid of it. Now, how do you get rid of it? The answer is we have a method called dispose on the object returned from subscribe. Now, you might say, why don't they have an unsubscribe method? Well, the answer is, what would you give the unsubscribe method? Exactly the same function as you gave it originally? Yes, that could work. But now there are some problems with composition. Say that you have two sequences and you merge them together. Now you have one sequence. If somebody subscribes to that one sequence, what do we have to do internally? We have to set up an observer for both underlying sequences. So we need to do a subscribe to the underlying sequences using some additional logic, because we need to make sure if both sequences complete, we need to complete. If one throws an exception, the other one should be terminated. Like, it's all entangled over there. But so we have two observers. Now, what do we do if somebody says, hey, I want to unsubscribe from that merged thing? He passes in his original callback function. We need to map that original callback function to the ones we need to get rid of in the underlying data sources that are being merged together. So we need those huge state matrices and state dictionaries to do that in an effective way. And that's not very good for composition. So instead we say we return disposables. Disposable objects are just objects that have a dispose function. And now if we do something like merge two sequences together and you subscribe, what you get back is a disposable that when you call dispose, it calls dispose on the underlying sequences. So you know the thing composes in both the data direction and the resource management direction. So that's the reason we actually do this dispose mechanism. And it has helped us a lot with, making the API much more expressive. So let's take a look at creating observable sequences. It's actually handy because, like, if the screen goes away, I can be browsing the web in the meantime. So actually, I like this. So I have a little template here, an HTML template. I just created file export template from some base piece of code. And I will just call this thing basics. And what this does is basically, it imports a number of scripts. It imports jQuery here. I will use that to talk to my UI. I'm importing RxJS, which is our main library, which you can just download. And I'm also importing two other things. So this is interesting on New York Times over here. I was reading in the meantime. So I have two things here, rx.html and rx.jQuery, which are two libraries that make bridges, and we'll look at those separately later, actually allow you to take DOM elements and just expose them as observable sequences. So in my ready handler, I'm going to create a new sequence, which I will call ticks, and it will be rxobservable.timer that fires every second. The first thing is the first time it fires, and that's the period. So after 1 second it happens, and then every second after that it happens again. Now I have an observable of something. The something will be an incrementing counter. The first time it will say 0, the second time it will say 1, and so forth. And I can subscribe to that. I can say ticks.subscribe, and now I either pass in an observer, or I pass in onNext, onError, onCompleted, of which the last two are optional. So you can do a lot of different mix and match things here. In this case, I will just pass in an onNext handler, which will be function that takes in x, which is the value of the timer, and that x value I will render on the UI. I happen to have something called results over here, so I can basically get the results and do HTML of x. So this is the way how you interact with this sequence. You basically do a subscribe, and then you write some code that handles the event coming through. So when I press F5 now, I will basically have a page that counts 0, 1, 2, and so forth. And you might want to say, I want to get the date out, the time out, because I just want to get like a real clock on my screen. How would I do that? Well, there are a number of ways you can do it. You could say, well, I don't care about this X thing here. The timer is ticking. Let's actually do new date.get or toTime string over here. And now I will have a clock on my screen, of course. I'm doing that logic now inside my event handler. I just have something that ticks every second. I still have an observable of 0, 1, 2, 3, 4. I just ignore that value and then project it onto, it's actually going, believe me, It's basically projecting it into some value, which is the time. Now, wouldn't it be nice if somebody says, I want to get an observable that contains data objects? How would you do that? Now I have a timer with 0, 1, 2, and 3, and so forth. Well, that other party said, I want an observable that contains data objects, or an observable that contains strings with the date in it. How would you do that? Well, not by writing imperative code in your event handler, because then you have to tell them, well, what you will get, I have to let you down, is 0, 1, 2, and 3, and you will have to do all that logic yourself. In Rx, you can say, well, I have a sequence, I can project the sequence onto something else. And this is really getting out of hand because, okay, whatever. The resolution was even switching while I was typing. So fancy effects. Weird. So what I'm going to do instead is I'm not going to subscribe to ticks directly. I'm basically going to say I want to project all of those values, 0, 1, 2, and so forth, onto datetime objects. I want to project them onto strings. So I'm doing a select just like you have a SQL select or a link select. I'm saying function of I don't care what the value of the timer is because it's just incrementing and that's not really worth much in my case. But I'm going to return new date.toTimeString. And now I have an observable sequence. When I subscribe to it, it will actually produce strings that contain the current date time. So when I do results HTML_X, actually the X will already be the string. Now, of course, you could envision that this lives in a totally separate file behind some nice abstraction that somebody says, I want to get just a clock that gives me date time strings. Well, now you can just encapsulate it in a function that returns this whole thing. So let me say F5 on this, and obviously the whole thing still works, but I don't have additional code in my event handler anymore. It's now all hidden in a query expression that does all the processing. Of course, there's more than just a select. So let's go back to the slides. And before we actually go into the query processing stuff, let's talk about how you create observable sequences in reality. Like you do observable.range and observable.timer. Those are all very useful, but you say, where are my DOM events and where are my AJAX calls? Well, let's take a look at that. But before I go there, let's start with a sample of HTML5 geolocation, because that's an API that's event-driven as well. And here I will basically show you, if we don't have a way yet in Rx to basically import one of those new APIs as an observable, you can still do it yourself. So I'm basically showing you how to implement an iObservable wrapper around any kind of API. That's what you're seeing here. So what I want to do is I want to create a sequence, geo, which contains JSON objects with latitude and longitude coordinates that come out of it. And the way that the user will actually use it is by subscribing to it, and then given that function that takes in a position, this is really annoying. Given that position that comes out, I will alert it on the screen. Now, of course, you could also talk to Bing Maps or any other mapping component to basically move like a little person that's moving on the map whenever you drag your laptop to another place, you want to update the map. But so imagine that anything can go in the subscribe call, of course, depending on what you want to do. So how do I fill in this rx.observable.create, which is sort of the mother of all creation operators? So what you have to give us, in order for us to encapsulate your logic as an observable sequence, you need to give us a function that implements the subscribe method. Now, the subscribe method or function takes in an observer on which you can signal values out. So for example, if you would do observable.return using observable create, you would simply say, hey, they give me a subscribe function here which takes in the observer. I'm just going to do observer on next 42, and that's the value of the return that comes out of it, right? You can just talk to the observer inside this body of code. Obviously, I don't know what my coordinates are. I will have to talk to somebody else to do so. If this frequency increases, I'm going to cry. You don't want to see that, so fingers crossed. So what I will do in the subscribe call here, the first thing is I will basically register callbacks on watch position, which is the API of geolocation. Now, watch position takes in two things. It takes in onNext and onError. The onNext basically says, here's the new position. It happens that the position contains some fluff as well. It contains like a timestamp when things have been generated. It contains much more than I need to know. So I basically do observer onNext with the position.coordinates whenever this thing happens. Now, when an error actually comes out, we basically tunnel that out on observer on error, basically saying something terribly went wrong. Now, that's not the only thing you do in observable.create. You also need to return a way to unsubscribe. You basically return a function that gets called when the user says dispose on the observable sequence registration. And that basically needs to make sure that the handlers, the observer on next, observer on error, cannot happen anymore. The way to do that with the geolocation API is as follows. You say, I want to clear the watch. How do you clear the watch? You need to know what the watch ID is. Well, the watch ID you got when you actually did watch position. So basically, you have a little bit of state floating around here that when the user calls dispose, that little function where the text balloon is will get invoked and will actually tear down the watch ID, and the geolocation API will not call my callback functions on the top anymore. Now, in order to show this, I'm using some new feature. It's called Visual Studio PowerPoint Edition. So I'm going to step through the code over here, showing you the order in which things evaluate. So I set 2 breakpoints here, a breakpoint on next, which is the producer side, where the geolocation API says something happened. And I also set a breakpoint on the consumer side. And in reality, those things will live in different files, right? You will just write one time rx.geolocation.js, which has just the top part encapsulated, and then you will have the thing at the bottom. So the bottom thing is what users will write most of the time. The top thing is something that somebody does one time. So let's press F10 and see what happens. I'm basically stepping through the code. First thing is I have a huge statement here, observable.create. Now, when I do F10 on that, nothing inside that observable.create is executing. Well, something is executing, but it's not the function that you gave us, because the function will get called upon subscription. This whole thing is lazy. Nothing happens until somebody subscribes. And every time somebody subscribes, the function will get invoked. I will wait for the screen to settle because the animations are too nice to be spoiled behind the black screen. This is interesting. I think we need Rx to display adapters or something. OK, let's try again. So I press F11 on the subscribe call here. Let's see where we end up. When I do F11 on that, I end up in the function that was passed to create, which is the implementation of subscribe. Now, the thing I'm doing here is I'm basically calling the watch position API, saying this is the way to tunnel out results. Now, when I move on here, the next thing we're actually going to do is we're going to return a function that, given the watch ID, is capable of unsubscribing. Now, there's actually a very nice effect coming up in just a moment. So bear with me. There it is. When I hover over the watch ID, yes, it's actually just basically to keep the suspense up that I have this flickering screen. But you see the watch ID here is 787380. Please remember that number because we'll see it later. You can remember it by thinking about big airlines or airplanes. So given 787380, that's now stored in the closure of the unsubscribe function so that when somebody calls unsubscribe later, we'll be able to get rid of that particular call that we made to the API underneath us, the geolocation API. Now when I execute, the satellite is beaming, and what's happening now is that the geolocation API is calling us back, saying the long and let coordinates are those values. We are now in the producer side. We're on the edge where the geolocation API talks to Rx through our little bridging component we've built here. So now, when I actually press F10, through the on next call that's basically implemented in part by Rx and in part by the consumer at the bottom, we ultimately end up with alert of the position, which is still the same value. Nothing happens magically to that value. And when I press F5, obviously, we get to see the dialog that says this is the value. Now, when I dispose this dialog and assume the code is running the ellipses at the bottom of the screen, the 3 dots, somewhere in the future, somebody's going to say d.dispose. Maybe because somebody says, I'm tired of this, I'm just checking a checkbox, please turn off my geolocation API readings. What's going to happen then? Well, d.dispose, when I step into that, I basically end up in that function that's returned from observable.create, which is used to unsubscribe. And if you look at the hover-over effect here, again, we see 787380. If you would have multiple subscriptions, each of them would have its own value for watch ID, which is carefully tracked by the closures in the JavaScript language, so it just works out very well. So at this point, we clear the watch, and from that point on, if everything goes according to plan in the geolocation API, I should not get any callbacks in the future. So that's one way to do it. That's basically saying I have some API, I can just wrap it using observable create once and for all, and then I can use that multiple times. Now, of course, it happens that Rx has already implemented some bridges for APIs that existed before HTML5, such as the HTML DOM. So here I have a sample using rx.observable.fromDOM event, and the fromDOM event takes in everything we need to know in order to hook up some event handler. In this case, you say, I want to have the mouse moves on a canvas. So I just give those arguments, and now when I subscribe to that, what happens behind the scenes is we cook up some event handler, we give it to the onMouseMove function that lives on the DOM, and we return some function that, when invoked, it will basically unregister the event handler. So we encapsulate that it's actually implemented using observable create, as we saw before, but now using some different calls to the underlying API. And of course, the event handler simply calls onNext on the observer, saying here's the next value. So it's just tunneling out. Now you can also use jQuery syntax. We actually have rx.jQuery.js, where you actually have operators like this from jQuery, where you can use all the familiar syntax that you've used before. And in this case, I'm listening to the click event on div and span tags or elements. And then in the callback function, I'm basically saying where the mouse is at this point in time. Of course, instead of doing event.pageX and event.pagey in my handler, I could have used the select. I could have projected my sequence of DOM events into a sequence of JSON objects containing X and Y. I could start shifting logic around here if I want to. Here's an alternative way of writing. We also have a toObservable function that you can use on this jQuery construction, and then ultimately you can do subscribe in exactly the same way as you did with the top piece of code. So given that, we've seen how to deal with UI stuff typically. How do we deal with things like AJAX? Again, we have a bridge. It's called the XML HTTP request bridge, which is used in here. So what we do here is we basically do observable.xml HTTP request of a certain URL, and what comes out there is what would come out of a regular XML HTTP request response, which is some object in which you have to dot to the data, in this case response text, which, because I requested the results as JSON, I will evaluate. Once I evaluate that, I get the response, which happens to be an array, and then I can fish out the little piece of data that comes out of the API, which happens to be at index 1. I will actually show you the documentation for this API that actually details where you can find the response to the XML HTTP request. But at this point, when I call search Wikipedia using a term, I get an observable back that has basically an array of the responses that belong to that request. So it's basically a sequence that contains a single value that's given at you as soon as the AJAX request is done. Now you can do things like, well, search Wikipedia for reactive, and you can use Rx to say, for example, .timeout after 5 seconds. If the request doesn't come back after 5 seconds, please Rx dispose it for me, don't give me any results back, and call the onError handler to say that a timeout exception occurred. Like now you can compose that sequence with timeout. Just like you could do a timeout on mouse moves, saying to the user, hey, you're not moving your mouse. Is something happening? Do you feel bad? Here's some advertisement to get some pills. Like, you could totally do that. It's all observables. Like, it doesn't matter what you're doing. So let's take a look at bridging with the existing world. I actually have prepared some of the samples that I want to use here. Could also start writing them. It depends on the time. Let's actually drag in one of them, which is the geolocation one, which I already looked at before. So that's the geolocation sample, where I have watch position as observable, which is exactly the thing you saw in the slide. It's basically observable create given the subscription function that first sets up the callbacks that's happening over here by calling watch position, and then ultimately I return a way to get rid of the watch that's actually registered by the geolocation API. Okay, now squeeze and look at this piece. It's really funny. Now my UI basically looks like this. I have a checkbox called track position. When you actually check the checkbox through some jQuery magic that I'm too stupid to understand actually, when the check is actually happening, I'm basically setting up watch position as observable. I'm subscribing to that thing, and what I get back is a disposable object. Now, if I store that disposable somewhere, I have scoping here because I'm inside a function, so it sort of pans out nicely. I just keep that D around so that I can unsubscribe later on. This, of course, assumes that checked and unchecked are balanced. Like, you can't have two checked events because then you have two subscriptions happening. Like, ignore details that might be DOM API artifacts. But when I unsubscribe, when I uncheck the checkbox, as you can see over here, I'm doing d.dispose to basically get rid of the geolocation API readings, and I'm emptying the results. So when I execute this thing, I can basically click this. You see the results come back. Now I could walk around with my laptop through the streets of Las Vegas. If that's what the geolocation API promises me, they should actually be able to tell me that my position has changed, because that's what the specification says. I haven't tied that, and I can't tie it here because I have some nasty cable attached to my machine. But so this is actually what's going on. If I click on this checkbox again, and I set a breakpoint on a dispose call, you see I get to the dispose call over here, and now when I step into that, I will ultimately end up in this piece of code that takes away the watch. So you see the watch ID was not 7874380, it's actually a meaningful number that starts with 1 for some reason. So I will take away that watch, and I will not get callbacks anymore from the API. So that's the geolocation sample. Let's actually show another sample here of using AJAX. I'm not going to type them because my eyes cannot stand this flickering effect, so it's good that I have those things sitting around. Now here's a way to actually import an AJAX-based API. So here I'm doing AJAX as observable. We also have from XML HTTP request. We have many ways typically to do it. Ultimately, the result is an iObservable of some result type. In this case, I'm using just some JSON, some protocol here to get the data back, and I'm passing in the settings to AJAX as a JSON literal. It contains the URL, the data type, and the data, which contains the action to invoke on the API. So in this case, I'm using something called OpenSearch. When you look at the documentation over here for search suggestions, that's basically what I'm using. I'm passing in the search string. I could pass in the limit, the maximum number of results that can come out of the API call. And ultimately, what I get back is something that looks like this. I get back an array that contains first the word I gave it, likely to correlate things together if you have multiple requests in flight. And then here I have the array with the results that come out of the API call. So I will actually extract that out of my response from the API. That's what I'm doing here. d.data sub1 is basically just getting that part out of my response. And so at this point, look that I've already used the select here just to encapsulate all the logic to get the response back. Now I have a function that, given a string, which is a term, of course you can't guarantee it's a string in this case, but given some term, I'm basically going to the API, and what you get back is an iObservable that when you subscribe to that, that thing is in flight, and in the future it will tell you when the results are ready by means of an onNext call. This is what I'm using here. I'm basically searching Wikipedia for React, and then I'm subscribing to that, and now it could be that this callback function here gets invoked immediately. If we're lucky, it might get invoked 1 day from now. Just depends on how the Wikipedia website actually feels that day. So, and I will just render things here by emptying the results and then doing a for each loop over the words using some JSON constructs and just appending list items for all the words that I got back. So when I actually press F5 on this thing, you see, well, it happened almost instantaneously here. The results came back as soon as the AJAX API completed. So now let's see how we can do more than just a select. Because, well, select is beautiful, but of course Rx is about many more operators. You see the list is quite big. So we want to use a little bit more here to make the sample a little more compelling. So let's switch back to the slides and talk about query operators for just a moment. So what I want to do is, standard sample for Rx is Wikipedia suggest in this case. We also have dictionary suggest, whatever. But this sort of shows a lot of operators that sort of work in concert to do a nice example. So what I want to do is this. You have a text box, the user types some words, for example, React, which is represented now not just as a DOM event, but it's encapsulated as an observable of strings, which happen every time the user presses a key. Now, with the word that actually comes out of that call, I'm basically going to make a web service call to a dictionary web service. In this case, it's just going to be the Wikipedia service to tell me what are all the things you have in your dictionary that start with the word React or with the term React. Now, notice the coins on top. That's not just decoration because we're in Las Vegas. It's actually intentional. The idea is that every web service call might cost you some money. Like every time you go to that service, it might be a paying service, you need to pay $1. Now, of course, you want to optimize things here. You don't want to go to the web service every time the user hits a key. You want to tame that sequence down somehow. And that's something we're going to do using Rx in just a moment, so we'll actually save money and put the rest aside to do some gambling tonight. Now, ultimately, the dictionary web service is going to come back with an AJAX response, which is represented in our case as an observable of arrays of words. There will be just a single array coming out of that because, well, we're just making a single call, but the array will contain all the words that start with the term that the user actually gave us. So how do we do that? So here I have some search input that will come from the UI. And here I have a way to import the input sequence as a sequence of strings. Using input.val, I'm basically projecting the input onto a sequence of strings. So this is an observable of strings. When I subscribe to it, I will basically get an event handler for the key up event from the DOM API. I just wrapped it and got some meaningful information out of it. Now, the next thing I'm going to do, and I'm going to show it just in a moment inside Visual Studio, is I do not want to go to the web service, which will come later in this slide, every single time the user types a key. I want the user basically to slow down and not type anything within a window of 500 milliseconds before I take up that value and send it to the web service. Now, if you want to do that manually, like that throttling of the input sequence, well, good luck to you. You have to start some timer and wait for the timer to happen. And if something happens in the meantime, you have to cancel out the existing timer, start a new timer. Like, it's a lot of state management to do this kind of stuff. In Rx, it's just composition. You have an observable sequence. Now you want to throttle it down. You say throttle with 500 millisecond delay. And then when you subscribe to that, we set up the timers and dispose them and do all of the stuff needed in order to make this happen. So let's actually cancel the slide at this point and already start showing this particular point here in Visual Studio. So let's actually start from scratch for this one because I still have some time. And I will call this suggest.htm. So I have my template sitting here. We'll add some stuff to it. I will start by adding a text box, which will be the input that comes from the user. And that will be an input element over here. And I will call that thing search input. So now I have just an object that allows me to type. Nothing fancy. And let's put a line break with my great design skills. Good. So now I have that. I want to import it as an observable sequence. The way to do that is I'm just going to cheat a little here. Going to import it as such. I basically use, in this case, I use jQuery to get to the search input. And then I do two observable on that to get key up events. Now, the key up events that come out of that contain some event arguments, and they might contain the text somewhere. I just don't know how to get to it. So instead of fishing it out of that underbar thing, I'm just saying return input.val. So whenever the user presses a key, I'm getting out the value just by asking the text box. If you know how to get it out of the underscore, that's fine too. I just want to get an observable of strings coming out of the system here. So I have an observable of strings. So let's actually write an event handler for that using Rx. So I can do res.subscribe with a function that takes in the term that the user is writing, and I'm going to put it on the screen. How am I going to put it on the screen? I'm going to go to the results tag, like this. Oops, not here. Okay. And I'm going to append the term that the user wrote to that particular element. So I'm just going to add a new line to that thing. and I'm going to put the term in front of it. So when I execute this thing, I can basically type here, and I just have an event handler. For some reason, there is a quirk in the keyup event that triggers multiple times for reactive at the end. I don't know why, but you get data out. Actually, that allows me to prove another point later on, how you can actually get rid of duplicates as well. But so you can just type here, and things are coming out. Apparently, they throttle a little bit for us as well, which is nice, but they don't quite throttle enough. This is too much of data that basically appears here and is sent to my web service if I would continue writing my code. So how do I throttle this thing down? Well, the answer is not by creating timers. You basically say .throttle of 500 milliseconds, which means if the user types something new within a window of 500 milliseconds from the previous event, we basically don't send out the previous event, and we just hold on to the current value until the user waits longer than 500 milliseconds, then we forward the event out. It's just like IntelliSense in Visual Studio. When you actually do IntelliSense stuff, they don't bring up that thing immediately. You might not actually see that, but they told me that it takes like 150 milliseconds or something before they bother you with that dialogue, which corresponds to some biometric measurements of the human eye or whatever, which I don't know anything about. Definitely not after today with this flickering thing. So let's press F5 and see what happens now. If I type reactive really fast, I can even correct myself. Oh, it's still going. Now I wait 500 milliseconds, it comes out. I haven't gone to the web service for all of those intermediate results. Rx is starting a timer whenever a new value comes in, canceling the previous timers, holding on to the current value, sending out the current value if the timer expires, then canceling out the existing timer. So we are doing all of that stuff behind the scenes. Now, I can, of course, go back to React, and we launch a new web service request, do reactive again. That's very nice. Now, what if the user is smart and he does this? Oh, I'm canceling out within 500 milliseconds the IVE part of reactive, and I get duplicates in my stream. Well, I could go to the web service with reactive multiple times, but it will yield the same result anyway. Why would I want to do that? Well, how do you filter out adjacent duplicates? Well, it turns out in Rx we have an operator that does exactly that. You can do it manually as well. You just set up an event handler, store some field somewhere, so you need to have some scope, which contains the last value, and then when a new value comes in, you compare against the last value, and if the value is the same, you don't forward it, otherwise you forward it. It's not that simple if you want to do all of that logic, because you create an observer, object, and all of that. You need to have state management around. It's kind of getting complicated. So the way to get rid of those adjacent duplicates is by using a function called distinct until changed, which basically says, well, I have a sequence that produces react and then react again. Only the first one is going to come out until a new value comes in that's totally different from the previous one. So when I do this, I can actually type reactive. It's still being throttled. I can go back to react. Still everything is fine. I can do IVE. That comes out. I can go backspace IVE. Oh, now it doesn't come out again. The fact that I produce two reactives that are the same after one another. So you see that all that state management is now hidden behind a very simple looking operator. You can even pass in a compare function if you want to have custom comparison of two adjacent values. In .NET, you would pass in an equality compare object to do so. But you can pass in a function here that takes in two values and returns a bool to say whether they are the same. So you can extend this a little bit as well. So with this, let's go back to the slide and finish up by gluing this thing together now to the web service. Whenever the user types something, I want to call search Wikipedia given the term that the user wrote. Now, what's this going to produce? I started with a sequence of strings, which are tamed down and not, with adjacent duplicates. Now I'm selecting each term, which is a string, onto a call to search of term. Actually, it should be spelled search Wikipedia, but the screen is not wide enough to do so. But that's the function we saw before. That takes in a string and returns an iObservable with an array with the results. So the result of doing this select is an observable sequence of observable sequences, one representing every request. So we basically have some nesting going on. It's a higher order API. You can do all that fancy stuff. Now, how do I flatten that thing out? How do I say an observable, which corresponds to every word that the user types, with inner observables that represent AJAX calls that are in flight? How do I make sure I just get the last one? I want to cancel out previous ones if the user is fast enough, and just tunnel out the results of the last outstanding iObservable in that nested contraption. The answer is using an operator called switch. What switch does is an operator that basically walks a staircase. That's the way I compare it. So imagine a staircase that looks as follows. You have a big line, which is the outer observable sequence. And whenever a piece of data comes in, a term, we create a new inner observable that represents an AJAX call. We are not blocked for that. That AJAX call is in flight. Then the user types something new. We get a new AJAX call that's happening here. And they're all in flight at the same time. Typically, one will complete before the other, but because it's networking, you never know which one will come back. Now, how do I basically jump from the first inner observable when a new one comes in for the next term that the user is searching for to the second one? You basically want to jump to the next step in the staircase, and that's what switch does. It takes an observable of inner observables, and it basically walks the staircase, just taking the last observable. So switch basically says, hey, there is an inner observable. I'm listening for AJAX results to come back from the current request, which could be React. Now the user types reactive. What switch is going to do is it's going to cancel out the outstanding request to React, basically silence that AJAX call, subscribe to the new one, and tunnel out that one's results. It might be that that one completes before the user types something new. That's fine. But if the user types something new in the meantime, we switch to the next ones. We basically just switch to the next sequence every time. Now I can basically bind this to the UI. I can say words.subscribe, given the function which takes in data, and data will be a word array. I'm basically going to for each over that and bind them to the UI. So let's actually take a look at how we do that in practice. So I have already all of this stuff here. I'm going to import the search Wikipedia thing. Ought to be something with the graphics card. So I will take in search Wikipedia, which is the function we saw before, that takes in a string and basically returns the array with the words that match that string inside an observable. So this is a function from string to observable of word arrays. Now, how do I combine the two? For every word that the user types, I'm going to write a function here that essentially takes in the term that the user wrote, and I'm going to return search Wikipedia of that term. So now I have a sequence of sequences. For everything the user writes, throttled and distincted, a new sequence is born that represents the ongoing web service call to that particular Wikipedia request. And now I want to switch them, meaning the last one is always the one that's current, and the previous ones get disposed once a new one comes in. So I do switch on that, and now I have, let's see whether I can type blindly in the meantime, I have results coming out which no longer contain terms, but now they contain words that come back from the web service. And now for every word, I need to iterate over that, which I can do by emptying the results first, and then I can do each over the words with a function. Index I will ignore. The word is the element I'm interested in, and I'm basically going to append those words to my results, like this. Okay? So I basically get the array back. I empty the current results view on the screen, which could be a list box or any other control that you're interested in. And then I'm basically adding the things to the screen by using the each loop. So let's try that. I press F5, I type reactive. It takes 500 milliseconds. And then the call gets propagated to the web service, and it returns almost instantaneously. I can go back here and do react. You see that's still happening. I can trigger, those distinct things which do not trigger a new web service call. If I would use something like Fiddler, you would see there are no new web service calls being born if I do this kind of crazy stuff within a window of 500 milliseconds. So you see that now I use just observables to compose UI events together with AJAX calls. And you could compose all of those things. Like if you want to mix in the geolocation API, fine. If you want to filter that you can only search for casino if you're in 10 miles from Las Vegas, well, you can write a where query that does that. Just by looping in the geolocation API, having a function for distance, whatever. So you can do that now because everything is an observable sequence. So maybe the machine is saying that now it's really time to stop, which it actually is because this is my summary slide. So can Get the Reactive extensions today. We have them online at msdnmicrosoft.com/data. We have distributions for .NET 3.5, .NET 4, Silverlight 3, Silverlight 4, XNA 3.1, XNA 4. Windows Phone 7 is actually built into the ROM of the device. So if you have a Windows Phone 7, it's baked into the chip. You will find it in the namespace Microsoft.reactive, so you can use it immediately. We have updates available. You know, we ship quite frequently new updates with new cool stuff, so you can always get those. If you use Visual Studio with NuGet, you can also import just the NuGet package. It's called Rx spacebar all or Rx-all. You can ask questions on the forums. They are very active, and actually I have a couple of people in the room here, like Jim Woolley and Richard Hine, and maybe some others that are active on the forums. So thank you guys for being such great contributors to our forums. We can't keep up with moderating. So, you know, please continue doing that. So also, if you have questions, those are the two guys you want to talk to. Then I can go to the party afterwards. So the forums are over there. We also have a couple of blogs. Actually, Matthew Podwasaki's blog is the most active with regards to Rx currently. We are sort of heads down implementing stuff. He's implementing a large part of RxJS right now. And in fact, you know, he still finds the time to blog. So I don't know how he does that, but a big thanks to Matthew for continued interest in RxJS and sort of spreading the word there. So you might want to look at those blogs if you want to get some more information about Rx. With that, I want to thank you for your attention. Please fill out the evaluations. If there is a section about technical problems, please use that to complain about the projector or my graphics card so that it doesn't reflect badly on myself. If you have any questions, I will be around here. I will also be at Ask the Experts tomorrow, almost the whole day. Actually, that's what I intend to do. So if you come there, I will actually have a huge logo with Rx on it because we don't actually have a separate booth. But so you basically look for this big logo over there. I will attach it somewhere to the wall, and there you will find me explaining everything you want to know about Reactive extensions. So with that, thank you very much for coming. Enjoy the party tonight, and see you later.